Okay, so just as an introduction to Activity 116, which is going to be in Multisim. Let me hit autofocus lock so that doesn't keep doing that. I want to give you the idea of the basic idea of what you're going to do, and then the shortcut in Multisim, so you don't think you have to build all of these from scratch. When you are finished with 116, you can have it all in one document. Which, friendly reminder how to make your paper bigger is go to Options, Sheet Properties, and then the Workspace tab, and you can change the sheet size. So this, you can see I was on only a size B, and I fit everything on. And if you ever run out of space for an activity and we want to keep it all in one file, just pop back in here and just go up a size to give yourself a little more space to work with. Okay? All right. So the idea... All right, is that you are going to build these little teeny circuits. And this is not like a regular circuit. This is like a logical circuit. And we're going to have a truth table that we're going to fill out with ones and zeros. Okay? And so we're going to have a 5-volt source and a ground. And 5 volts, the present of voltage, is going to be interpreted by the digital circuit as a 1, kind of a logic 1 or true. And then a 0, the ground, or 0 volts, is logically interpreted as a 0 or a false. So think kind of in true and false or ones and zeros. We are going to put a little switch into these circuits that can toggle between, having the ground flow through, so no voltage, or we can flip the switch. This is kind of like a railroad track. It's going to flip up the other way and go to the 5 volts, so it's going to have voltage that'll flow through. And then the 5 volts is like a logical true or 1. Okay? And what we're really trying to interpret and decipher and understand are these gates. So this little guy is a gate. This particular one is called an inverter. Okay? And so we only have one input to an inverter. And so we only have two things to test. Test when the input is a 0 and test when the input is a 1. And you get to see my answers right now. So the 0 became a 1 and the 1 became a 0. It's called an inverter. So it's why do you think we call it an inverter? Just switches the value. It inverts it. So how to build these? You have at the front of your workbook, reminder, you have this chart, and this is going to help you find in Multisim where to go grab these components. So this is the group at the top. And then it's the family, and then it's the item. And so here's the inverter gate. So you'll be able to find them probably by picture, maybe faster than name. If you kind of scroll through here, and then it'll show you. Now you see all these are like TTL74LS, TTL74LS. You're going to kick up on this really quick in the patterns, and a lot of things aren't that hard to find once you kind of get the hang of it. So I found myself not using one of these cheat sheets that my teacher gave me this summer. I used it a little bit, and I kind of made sure I had it, but I really got pretty good at remembering stuff for the most part. The switch is right here on that front page. SPDT, we go to basic, and then switch. And so, I don't know if you need anything. The probe, they also have probes. So indicators, that's under indicators and probe. So I think you need a switch, you need probes, you need the power, so VCC, the power, and the ground. Okay, those are under source. But anyway, you've got this to look through and find stuff, right? So don't forget about that. Now, if you really were home and doing this, we would want to get you logged into Multisim Live and do our best to do it on Multisim Live, which is a web-based version. It works a little different, but you can still do this activity there. So, let's go to Multisim, and I'm going to just make my paper bigger. Give myself a little extra space, white space to work with. And, I don't know, is it helpful to make one from scratch? So if I go, let's see, place, component, let's go ahead and make, I'll make the second one. It was, right, I need the power and ground. So I'm already on the TTL menu, so let me grab it. It's the 74LS08N for that one. So since I just happened to be in here, 74, right? You can see I'm on TTL, and then TTL. Why isn't it populating family now? That's weird. Well, let's try that again. Place component. Did I? What in the world is going on? You guys are like, Mr. Orlando, you don't know what you're doing. I've never had this not populate like this. In the wrong what? No, it's like, like master? Good guess there, Luke, but I think it's supposed to be on master. Let me type 74LS08. It's like something's not working. I've been having a lot of computer problems today. Let me just relaunch Multisim and see if that fixes it. All kinds of problems. So I'm going to go place component, and I'll grab the power, I guess. So it reset by restarting. I'm going to go to sources, power sources, and I'm going to grab VCC for the power. Okay, down here. So not the regular DC power, but VCC. I'll place that. And then I'm going to place the digital ground. There. All right, I'm going to place switches, which was under basic for the group, and the family were switch. And there's all different types of switches. And it was the DPST, right? No, this was, okay, SPDT. So it's a single pole double throw switch is what it stands for. It tells you right here the function. So I'm going to say okay. I'm going to rotate that though by hitting Control R to rotate, and I'm going to use 2 of them. So I'm going to do that, and then I'll just copy and paste and have 2, and in that orientation. So I want the orientation where the kind of I can have 2 different inputs to the switch, like ground or power, and then the output. So I might as well go ahead and connect the wires. So I'm going to have the top go to the power, like that, for both of them. And then I'm going to move my ground out of the way a little bit. That. And then I'm going to have the other pole to the ground. Now, I'm going to color code that. I'm going to have my ground be black. So I can go to the wire that's going to the ground, and I can right-click on it, and I can choose segment color or net color. Now, if I choose segment color, it's only going to get the little section of wire that got highlighted. But if I choose net color, it'll see the web that's all connected, and it'll get them all. So this brings up a color chart, and I'm going to choose black and say okay. So I got basically ground is black, so that's 0 volts, and then red is the voltage that's coming in. Okay? And then for this first activity, the one that I was doing is number 2, I needed the gate, which is referred to logically as an AND, model number 74LS08N. So I'm going to go place component, and I'm going to go to the TTL group, and then the 74LS family. And then these are, it's kind of like alphabetical order instead of always numerical. So like your 100s can actually come before the 20s because it's just seeing the 1. So it's not exactly numerical order. It kind of is and kind of isn't, right? So it's really alphabetical order how it sorts. So whether it's 74LS1, all the 1s are going to be listed before all the 2s, whether it's 1 or 10 or 100. So I wanted 08, 74LS08N. and it tells me here this is a quad 2 input AND. I'm going to say OK. This little guy pulls up. I'll explain this later, but for now, maybe just pick the kind of A, B, in order. Just grab that. I'm going to place this. It doesn't have to be exactly as it's arranged, but they in the chart they show kind of that top lead in line with that first switch, and maybe that looks nice and neat. And that's it. I don't need another one, so I'm going to hit cancel. And I'm going to go ahead and connect this switch to one input of the AND gate, and then the other switch to the second input. Okay, and then I have an output, but the output is going to go to a probe. The probe is an indicator to kind of tell me, is it true or false? Is 1 a 0, or basically do I have voltage or no voltage? And so there are some probes. If you guys had brought in the ammeters and multimeter tools, there's some probes here. Those, they work. They're basically the same. But the one in the activity, I believe they got, because there are different ones. They went to basic, right? No, went to indicators, and then went to probe, and then I think they chose just the plain digital probe. I believe that's the one they got. Okay, and then they used 3 of them. The reason why they did 3 is, I know we can see the switch, but they were giving us kind of a secondary way to see the value of the switch. And the output. So the output goes to one probe, and then they tied these probes into the 2 inputs going into the gate, which is really coming out of the switch. So this will go to the first wire, the first input, and then I'm going to run this one down to the second. And I can hit escape if I don't like this. I can always maneuver my wires slightly differently. And I'm just going to tie that in right there. So these are just offshoots to kind of get a probe, get an indicator of what is in this wire. So it's just going to sense, is it a 1 or is it a 0? Does it have voltage or no voltage? So now I can simulate. All right? And what I'm going to do and test with simulation is I'm going to try all the different combinations of these 2 switches in different positions. So on my chart, okay, so X and Y, I'm going to test 0, 0, which is ground, ground. I'm going to try 0, 1, so the X being ground and the Y, the second switch, being 1. Okay, then I'm going to reverse them and have a 1, 0, and then 1, 1. So we can go through all the different possibilities. So 0, 0, and then I would record, what is this showing? With 0, 0, my output probe is off. It's a 0. Okay? What happens to the probe is you get those little lines when it's on. So that's that input's a 1. That's not my output, though. So with a 1, 0, I have a 0. I'll toggle both of them so I can test 0, 1. Still 0. And then lastly, I'll test 1, 1. So when I have voltage to both, so that's really a 1, 1, I get a 1. And this is a logical AND. All right. Little things. If you look at the activity and you see, oh, they've got labels X and Y and Z and X and Y, and I want to make it look exactly the same, you can, here, let me turn the simulator off. You can come in here and right-click on the component, go to Properties, and you can change labels. So instead of that being switch 1, if you want to call that X, you can change the label. So on here, I can right-click, again, go to Properties, go to Label, and change that to Y. So you can change labels. You can relabel your probes the exact same way. So I'm not going to take the time to do them all, but you can go in that way and change labels. The next thing I'm going to show is that I can take this whole thing, I can copy, I'm hitting Control-C, and then I can hit Control-V and I can paste it. So this is where you don't have to make the same setup over and over again. So the next one down is the 74LS00N. So when I'm ready to go on to the next problem, everything's exactly the same except this one gate. So here's all you have to do. Copy the whole circuit, paste it, select this, do a right click on it, and then choose Replace Component. So we're simply going to replace that one piece with, what did I say, a 0, 0n? Okay, you can go back into your TTL group and 74LS family, get the new gate, say OK. You have to select here. I'm just going to choose A, and I've got it. It's very similar looking, but it is different. This one doesn't have a little circle on the front, and this one does. I can turn the simulator back on, and I'm ready to fill in my truth table. Kind of going through testing all the combinations. 0, 0, right? 1, 0, 0, 1, and 1, 1. Recording the outputs, and then trying to make sense of it. So there you go. There's a quick intro to doing activity 116. So when you're done and ready, that's what I'm directing you guys to just kind of move straight into there from doing 115B.